Okay, so recording. All right, I think we are about 50. It's about time to begin. So guys, let me find that. All right. So over the past 10 years, I have had the chance to meet and collaborate with several young, promising scholars of ancient science. And to my eyes, of these people, Dr. Sara Panteri clearly stands out. I have met Dr. Panteri about 4 or 5 years ago when I was living back in Berlin in a PhD candidate interview, in fact, which is, I have to confess, a very uncomfortable situation to meet people, especially if she is the candidate and you are a member of the selection committee. But over the years, we have developed a strong academic and personal relationship. Thus, I am extremely delighted, excited to welcome both my friend Sara and my colleague Dr. Panteri to our meeting. The topic of today's lesson, as you have been informed, is Eratosθένης or Kyrineos. And Sara, I would like to thank you once more for accepting this invitation. The floor is yours. And you can arrange question times or breaks as you wish. I don't want to say anything. The floor is yours.
Thank you very much, Michalis, for your presentation. Thanks to everyone for being here. And yes, unfortunately, I don't know modern Greek, so I will give my presentation in English, but I hope that everyone is able to follow and to ask questions afterwards. And it is for me a pleasure to be here, and that Michalis invited me, as he said, in Berlin. And it was an important meeting for me because I was basically introduced to ancient Greek science thanks to him, and I am very grateful to what I learned from him. So yeah, as Michalis said, I have been studying at Humboldt-Universität as a PhD student. And I have just submitted my PhD dissertation on Eratosthenies of Cyrene. Since Eratosthenes of Cyrene is such a big figure, a polymath, I decided to focus on a specific aspect of his activity, which is philosophy and mathematics, his philosophical and his mathematical activity. And I will explain you why I choose a specific field during my presentation. So now I will share my screen because I prepare a PowerPoint. And so I thought of organizing, okay, now you all should see it. I thought of organizing my presentation in the following way. Namely, I will first introduce Eratosthenes as a scholar overall. So I would like to give you a broad picture of his activity. And then afterwards, I would like to focus in the second part of my presentation, I would like to focus on the letter written by Eratosthenes addressed to King Ptolemy III, where he explains his solution to the problem of doubling the cube. And the reason for choosing this specific piece of text is because, of course, I work on it for my dissertation, and because it's an extremely fascinating piece of writing for me. And there are so many things in it, so many puzzles, so many things to think more about, which I thought that you might have enjoyed. And so I hope that it was nice for you to read it, and your curiosity was actually stimulated. So let's start with the beginning and with Eratosthenes, how the tradition talks about Eratosthenes' biography. The title of this first section is The Importance of Being Beta. And the reason why I choose this title is because for some reasons, Eratosthenes was attributed many nicknames in the tradition. And one of these nicknames is Beta, the second letter of the alphabet, of course. And why did he get this nickname? He got this nickname because the idea is that he was such a polyhedral, such a polymath, such a polyhedral figure, and he worked in so many different fields of study that he was never able to actually reach the first position in any of them. And so for this reason, he was nicknamed Beta. And another nickname that we are going to see is actually Pentatlos, which gives more or less the same taste of Beta, because the idea he is of an athlete who is not specialized in a specific kind of competition, but rather is a pentathlete. So he's able to do more than one specific sport. So this is actually, I thought that it was nice to tell you actually my first approach to Eratosthenes was during my master degree, during a course in Greek philology. Our professor gave us to read Pfeiffer, History of Classical Scholarship, which is a fundamental book in the field of philology. And this is what I read under the chapter on Eratosthenes. And this is the reason why I got interested in this figure in the first place. So Pfeiffer writes, Eratosthenes, born in Cyrene, was said, like so many others, to have been a pupil of the Cyrenian Callimachus. But the difficulties of verifying the scanty biographical data and reconstructing the contents of his books are nearly unsurmountable. Nothing is left to us but hundreds of scattered scraps, and there is not even a reliable modern collection of his fragments. Of course, for a young student and for someone who was thinking about trying to get into a PhD program, these words were extremely powerful, in the sense that I saw behind them the possibility to do original work. And this is the reason why then I started to dig more into Eratosthenes to see what Pfeiffer meant when he said that reconstructing the contents of his books is nearly unsurmountable. I wanted to understand what he meant with this expression. So as I said, first of all, we need to gather some biographical information on Eratosthenes. And the first place to look at is always the Suda. The Suda, which is this huge, famous Byzantine encyclopedia, which was arranged around the 10th century. And here is just like the first page of the Suda in one of the many manuscripts which report it. And here is the page where we have the entry of Eratosthenes is in one of these manuscripts. This is a manuscript from the Laurentiana in Florence. And as you can see here, the arrows show you the entry on Eratosthenes, which is actually very short. Not all the manuscripts have such a short entry for Eratosthenes. There are actually some manuscripts which have a longer entry, like this one, which is a manuscript which is in Paris. And as you can see, the entry on Eratosthenes starts in one page and it goes on for like 4 lines, 5 lines, almost 5 complete lines in the second page. So here we do have more information on Eratosthenes. And so, of course, gathering all the manuscript, doing the critical edition, which was done in a magistral way by Ada Adler, what we get is the entry for Eratosthenes in the Suda. And this is what we read. This is taken directly from the edition of Ada Adler. And this is my translation. So I'm going to read it with you. I need to move this, otherwise I don't see. Okay, Eratosthenes, just 1 second. Okay. Eratosthenes, son of Aglaus, according to others, son of Ambrosius, from Cyrene, pupil of the philosopher Ariston of Chios, the grammarian Lysanias of Cyrene, and the poet Callimachus. He was summoned from Athens by Ptolemy III, and he lived until Ptolemy V. because of the fact that he was second in each field of education to those who reached the highest positions. He was called platforms, τα βήματα. Others also call him second or new Plato, others Pentatlos. He was born on the 126th Olympiad and he died when he was 80, for he stopped eating because he suffered from weak sight and left a remarkable pupil, Aristophanes of Byzantium, whose pupil was in turn Aristarchus. His pupils included Nasias, Menandros, and Aristis. He wrote philosophical texts, poems, and historical texts, astronomy or catasterismi, on the schools of philosophy, on the abscess of pain, many dialogues, and many grammatical texts. Now, the second paragraph I divided into paragraph myself, is not originally divided into paragraph. So in the second paragraph, where we get these three nicknames, there is something weird going on, because the word that we find is tabemata, which is platforms or also altars. And why do we have this word? So, of course, what we have, the reason why we have bemata in the edition of Adler, which is here, is because in the manuscripts we have bemata in actually all the manuscripts of the Suda, which report this section of the entry for Eratosthenes. We always find the reading bemata. And this is very curious. For sure, there is something. And to see whether Adler had some thought about that, we need to go to look at the critical apparatus of Adler. And in fact, what we find is this. So Adler says, what I'm writing in my text is bemata, but actually beta is better. And where do we find beta? In Pseudo-Ezechius Meursius. So Meursius is a Dutch scholar who edited Pseudo-Ezechius, and he wrote beta in the text. So apparently this is actually, so in fact, if we read Ezechius edition, Pseudo-Ezechius edition, and we say Pseudo-Ezechius because we are talking about Ezechius of Miletus, who actually, is not actually probably the author of the text that we call Pseudo-Ezechius, which is the Viris Illustribus. And here we have, in this text, we have a series, a list of many authors who are mentioned with some biographical information. And here we find an entry for Eratosthenes. And in this entry, what we find is reported here in the edition of Flack, which is the one Adler refers to. And here we do find beta written. And this beta, which we find also in the other edition that we find in the TLG. The reason why I put both Flack edition of Pseudo-Ezechius and Müller edition of Pseudo-Ezechius is because in the TLG actually you find Müller edition. So according to this reading, we get actually a better reading, which is that Eratosthenes getting close to the highest position was called beta. The thing is that what is curious is to understand whether in Pseudo-Ezechius himself, we have in the manuscripts which report the text of Pseudo-Ezechius, we have beta, or is actually a conjecture of Meursius. And it looks the case. It looks as beta is actually a conjecture of Meursius, so this Dutch editor of Pseudo-Ezechius. So actually we stay with the question, how do we know about beta? And probably the best option, the best text to look at for the reading beta is a geographical text, which is here. Marcianus of Heraclea, a geographer who wrote an epitome of a geographical work of Menippus of Pergamon. And here we have this line, Eratosthenes on beta e Calesan oi tu museo prostantes. So the heads of the library call Eratosthenes beta. So what I wanted to say is that it's hard sometimes to get information when you work with this text, because as being extremely naive, I just look at the Suda, I read it, I was like, the Suda is, we have a reliable edition of the Suda. For sure, what I will read in the Suda will make sense. I found Bemata in the Suda, and I was like, why Bemata? Then I checked the apparatus. The apparatus tell me, go to look up Pseudesichus. I went to look up Pseudesichus, and then I was like, but why do we find beta in Pseudesichus? Actually, what we find in Pseudesichus is a conjecture of this Meursius, who probably, because Meursius doesn't actually tell us, who probably relied on this other text, which is geographical text, where we find the fact that the heads of the library, of the museum actually, call Eratosthenes beta. So this is just to show you how complicated things can be, even for a nickname, in this case, the nickname beta for Eratosthenes. So, okay, besides the nickname, which is super interesting, I think, we get other information from the Suda. We get a time frame, so when Eratosthenes lived. The Suda tells us that he lived under Ptolemy III because he summoned Eratosthenes from Athens to Alexandria, and he died under Ptolemy V. And we get also a space. The space is first Cyrene, which is the hometown of Eratosthenes, then Athens, then Alexandria. Again, I will just refer to the fact that Eratosthenes' stay in Athens is actually controversial, in the sense that there are some scholars who are not certain that actually Eratosthenes spent some time in Athens, and I believe that he did. But this is just to tell you there are many complicated matters going on, and one of these is, for example, the fact that Eratosthenes spent some years in Athens, but I believe that actually he did. So why Alexandria? Why Eratosthenes was called to Alexandria? Of course, Alexandria at that time was famous because of the library and the museum. And under the Ptolemaic kingdom, of course, the library and the museum were built under, we don't know exactly if it was Ptolemy I or Ptolemy II, but yeah, for sure, it was with the first Ptolemies. And here I put the first page of an article which I suggest you to read if you have questions about the library, because I found it very useful also, yeah, in terms of how things work inside the library and the museum in Alexandria. And again, here we find a sentence which for a scholar is very interesting, because the author Erskine writes, in spite of the famous intellectuals who work in Alexandria, men such as Euclid, Callimachus, and Eratosthenes, the evidence for the museum and the library is very poor. So again, I guess more that I read about these matters, more curious I was becoming. So as the Suda tells us, Ptolemy III Vergetes appointed Eratosthenes head of the library and chose him as tutor for his son, Ptolemy IV Philopator. And this should have happened around 240 BC. Here is another complicated matter, because as I told you, the tradition, what we are told usually, is that Eratosthenes was, yeah, he was head of the library. The problem is that actually, the text which is the most important evidence for the names of the heads of the library is this papyrus, Oxyrhynchus papyrus, which was published by Grenfell and Hunt, the super famous papyrologists, in 1914. And what Grenfell and Hunt say about this papyrus is, but the most valuable part of the papyrus is the list of Alexandrian librarians in column 2, in the second column, which I reported here, which at last determines the order of the holders of the office under the earlier Ptolemies, and supplies fresh evidence for the much discussed chronology for Apollonius Rhodius. With him, the list begins, the name of Xenodotus having, of course, preceded towards the end of column 1. Apollonius, who is said to have been the tutor of Vergetes I, was succeeded by Eratosthenes and Aristophanes of Byzantium, and so on. Again, I would like just to mention to you that there are some scholars who actually raises objections in front of this papyrus, because actually here we are not explicitly told that we are talking about the heads of the library. We are told about the didaskaloi, the teachers inside the Ptolemaic family. And so this is another problematic point. So we need other sources to corroborate the idea that we are talking about the heads of the library. Then, so as I told you, the reason for the nickname Beta is that Eratosthenes was an expert in many fields of study. And in this chart, I show you more or less the main areas of interest: geography, astronomy, mathematics, chronology, philology, poetry, and philosophy. And here there are some examples of these activities, of these fields of study. So one, he is probably the most famous discovery of Eratosthenes, which is the measurement of the Earth's circumference, which is not a topic that I cover in my dissertation, unfortunately. Not because mathematics is not involved, of course, because you saw in the video of Sagan that actually mathematics is very much involved, and proportion theory also. But because it relates to geography, and it was not my intention to approach actually geography. So I didn't cover it, but is probably the highest achievement in terms of contribution to humankind, I would say. And then Eratosthenes is said to be the first who developed the so-called geometrical geography. This is what also Strabo tells us. A geographical research which is based on very scientific and geometrical ideas. Then he wrote also works related to chronology. He wrote an astronomical and poetical work entitled Katasterismoi, like Aratus, and I will refer to this text later. He wrote poems. A very famous one is the Hermes. And he also wrote a text on philology, Il Perites Archaias Commodias, on ancient comedy, which actually was very long, and where Eratosthenes paid attention specifically to the words used by author of ancient comedies, in particular Aristophanes, but not only Aristophanes. Okay, so from this very wide array of fields, I decided to pick up two in particular, philosophy and mathematics. Why did I pick up these two, and why these two combine? Again, I was reading, I was searching, and this is what I read in Fraser, Ptolemaic Alexandria, which again is a fundamental text for studying Alexandria during the Ptolemaic period. So this is what we find in Fraser in the chapter where he talks about philosophy. After the great achievements of the Alexandrian scholars and scientists, Alexandrian philosophy in the Ptolemaic period cuts a poor figure, for it is a feature of intellectual life which only took root in the city at the very end of the Ptolemaic period, and then in an uncreative, thought-influential form. Thus, the story to be told here is largely of negative significance. This idea that philosophy didn't have much space in Alexandria is an idea that we find in a very recent book published by Rivière, who I don't know if Michalis mentioned him already, but is again a pillar in the field of ancient Greek mathematics. And in this book, he makes a strong distinction between Athens and Alexandria. And he argues that Athens was, during the Hellenistic period, the center for philosophy, while Alexandria was the center for science. And he explicitly says Hellenistic scientists cared little for philosophy, and Hellenistic philosophers care little for science. Not only do Hellenistic mathematicians not respond to the new philosophies of the Athenian schools, they even turn their backs on the more obviously mathematical concerns of 4th century philosophy. So at this point, Eratosthenes turns out to be an exception. And in fact, actually, both Fraser and Ness have to acknowledge the fact that Eratosthenes was an exception. And I will show you the evidence which suggests that Eratosthenes was interested both in philosophy and in mathematics. And with mathematics, when I say mathematics, please do not think, I think of tamathemata in the sense of the array of disciplines that we can consider tamathemata for Plato. So arithmetic, geometry. So not just, I don't know, arithmetic or geometry. So what Fraser says is this, always in the chapter where he talks about philosophy. It seems clear that men of real distinction in this field, namely philosophy, were not to be found in Alexandria. In the 3rd century BC, there is only one philosopher of note in Alexandria, Eratosthenes, who in philosophy, as in all his other fields of activity, belongs to no school, though he was much influenced by Platonic ideas. And what we find in Ness is a single example suffice. Central to the engagement of science and philosophy through the Pythagorean Platonic tradition was music theory. The only attested piece of mathematics dealing with music theory in this period is that of Eratosthenes, perhaps in the context of his Platonicus, an idiosyncratic return to Platonic-inspired mathematics, a unique exception to the rule. The field that brought mathematics and philosophy together, music, seems to disappear in the Hellenistic era. Here with Ness quotation, we refer to a topic which is that of ancient harmonic theory, which I didn't know at the beginning, but it ended up to be the main topic of my dissertation at the end. So my dissertation, the biggest chapter is about harmonic theory. And so this is to show you that in both authors, we have the idea that Eratosthenes was an exception. And of course, I didn't know, I mean, Ness just published the book, but I read what you see in Fraser. And again, I was curious because Eratosthenes kept appearing in all the texts that I was reading as the exception, as the particular character, as the peculiar scholar, the one outside the group. And so I wanted to know more and to read more. So looking for philosophy and mathematics in Eratosthenes. So already the Suda, as I showed you at the beginning, tells us that Eratosthenes was called second or new Plato. And I thought that this was a very strong statement because not everyone can say it with such an important nickname. And the second thing that the Suda tells us is that Eratosthenes wrote philosophical works. The Suda says, Egraphe philosopha, and it gives also, the Suda gives also us some titles on the schools of philosophy, on the absence of pain. But the Suda is not, of course, our only source. We have other sources for Eratosthenes' activity, broadly speaking, because I'm still not talking about specific texts. I'm still talking about an overview of Eratosthenes and of his activity. So besides the Suda, another place to look at is Strabo. In his geography, Strabo talks a lot about Eratosthenes, mainly because Eratosthenes wrote a text on geography. But he also gives us some background about Eratosthenes' interests, broad interest, and among these, there is also the one in philosophy. And what Strabo tells us is that when he was in Athens, Eratosthenes had contacts, or at least more than contacts, he had the chance to reach, let's say that Eratosthenes highly regarded some philosophers in Athens, Then the question is whether he met them personally. And here we enter into some chronological issues. But in any case, what Strabo tells us is that Eratosthenes held in great consideration certain philosophers. And these are Arcesilaus, who belongs to the Platonic tradition. He was head of the academy at the time when Eratosthenes was likely to be in Athens. Apelles of Chios, who was again related to the academy. Bion of Borysthenes, who actually cannot be considered, who is a cynic philosopher, it does not actually belong to the main philosophical schools. And Ariston, who belongs to Stoicism. So Eratosthenes seems to have been influenced, or at least to have considered the wide array of philosophical schools which were available in Athens in the 3rd century BC, because of course, very famously in the 3rd century in Athens, we find still the academy and the peripatos, but then we find Stoicism and Epicureanism as new philosophical school of importance. And then Eratosthenes wrote a text whose title is Platonikos. And so if we put together the dots, now the Suda tells us that Eratosthenes was called New or Second Plato. Then Strabo tells us that Eratosthenes was highly regarded Arcesilaus, who was the Platonic philosopher in Athens at the time when Eratosthenes was probably in Athens. And then he wrote a text entitled Platonikos. All these things put together, of course, are very interesting. And the next step for me was to look at the fragments of this Platonikos. The title, by the way, is referred only twice. So we have only 2 occurrences of this title, both of them in Tionosmyrna, and I will refer later to Tionosmyrna. So although we have few scanty fragments of this text of the Platonikos, there are 2 interesting things about them. First one is that the testimony are almost all Middle or Neoplatonic philosophers. And these are Tionosmyrna, Nicomachus of Gerasa, Porphyry, Iamblichus, and Proclus. The distinction between Middle and Neoplatonism is problematic. So this is a very simplified chart, but it's just to say that are philosophers related to the Platonic tradition, which we could call in that period Middle Platonic or Neoplatonic, but yeah, just to say that they are related to Platonic philosophy. And the second very interesting thing, which is what Netz was referring to in the quotation that I reported, is that many fragments deal with harmonic theory and with geometry. Not going to talk much about harmonic theory in this presentation, but if you have questions, I will be happy to answer if I know the answer, because it's a very fascinating field. And I didn't know anything. I started to study and to learn more, and it's just very fascinating. These are, by the way, the division of the tetrachords, which are attributed to Eratosthenes in the enharmonic, chromatic, and diatonic genus. And this is the edition of Turing of Ptolemy, because they are reported by Ptolemy Harmonica. Second book, chapter 14. Okay, so on the one hand, the Platonicus focus on mathematical disciplines, especially harmonic theory. On the other hand, in other contexts where Eratosthenes contributed to or referred to mathematical disciplines, Platonic philosophy is involved. So one piece that I was able to gather is that the Platonikos, of course, as the title suggests, is related to Plato philosophy. And is not a text about ethics, about, I don't know, dialectic. It's a text which focuses about ta mathemata. And on the other hand, there are other contributions of Eratosthenes which are related to harmonic theory, to mathematics, to geometry, to the harmony of the spheres, where Plato is involved, where Platonic philosophy is involved. And so basically my dissertation ended up to be a gathering of all these elements, where both philosophy, Platonic philosophy specifically, and ta mathemata were involved. And so the big question for me became, how are the Platonic elements in Eratosthenes related to his mathematical activity? And these are more or less the fields, so harmonic theory. And here the main point of reference for harmonic theory in Plato is the Timaeus and the division of the word soul in the Timaeus. And this is related to Eratosthenes' own division of the tetrachord. Then the harmony of the spheres, which is the harmony in the heaven, is referred to by Plato in the 10th book of the Republic, very famously, and also in the Timaeus we do have the idea that the structure of the orbits is according to certain proportions. And Eratosthenes refers to the harmony of the spheres in the Hermes. And then there is the issue of the definition of geometrical objects, which actually is very problematic. But we do have a definition which is attributed to Eratosthenes, according to which the line is said, Eratosthenes says that the line is the flux, is the result of the ruses of a point. And finally, geometry, because of the problem of doubling the cube. And in the letter that you read, there is the reference to Plato. And, but besides that, of course, in Plato, we find in the Meno the problem of the problem of doubling a square. And basically the problem of doubling the cube is the parallel just in the realm of three-dimensional geometry, in the realm of stereometry, basically. And Eratosthenes gave a solution to the problem of doubling the cube, where Plato is involved, is referred to. And then we have another super interesting topic, which is the so-called topoi in reference to means, which, if you have questions, I can talk more about, is very problematic. So I would say, I think that I have talked already for like 40 minutes, more or less, 35 minutes. I don't know, we could perhaps stop here because my second section is going to be longer than the first one, and it is about the letter. So we will go through the text. So I don't know, Michalis, if...
We could have a break if you want. Just tell us how much time, and then we will resume like 15 minutes, 10 minutes, something like that. 7 o'clock, that would be fine?
Yes, perfect. That's perfect.
All right. I stop the recording now, and I will resume in like 15 minutes or something. Okay.
Thank you.
We are on.
Thank you. Then I share my screen again. Go. So, this one, okay. Okay, so now I would like to talk about Eratosthenes' letter to King Ptolemy. And this letter is very rich in content. And there are many aspects. It has a literary aspect, a scientific aspect, of course, but also a literary aspect, a philosophical aspect, a reference to mechanics on the time of Eratosthenes. It has pieces of poetry included in it, one that Eratosthenes quotes, and another one, which is Eratosthenes' own epigram at the end of the letter. So I thought that this was actually an example of Eratosthenes' activity overall. And also bear in mind that Eratosthenes is the son of his own epoch, let's say, and Alexandria was famous. The intellectuals working in Alexandria, the poets working in Alexandria were famous for writing these poetical works, which were full of sometimes mysterious references, They were authors of a poetry which was very polished, which was very refined, where attention was paid to all the details. And so this is the kind of interests that especially the poets and the grammarians in Alexandria had, which is anyway reflected in Eratosthenes, because he was both a grammarian and a scientist. And this letter, since it is considered to be Eratosthenes' original piece of writing, reflects this search for precision and for something very accurate, something very polished. So the first question is, of course, where do we find Eratosthenes' letter? And Eratosthenes' letter is preserved. So this is just like the pages of the letter, which I found in a very nice text, which was published in 1672. And yeah, so Eratosthenes' letter, where do we find it? We find it actually in a commentary on Archimedes. So Archimedes wrote a text entitled On the Sphere and the Cylinder. And apparently, this text was very famous and very important, to the point that we have even this story reported by Cicero, who found the tomb of Archimedes in Syracuse, and on the tomb there was engraved a sphere and a cylinder. So just to say how famous and how important was this treatise. And in the 5th, 6th century, Eutocius of Ascalon wrote a commentary on the sphere and the cylinder. And inside the commentary, while he was commenting the second book of the sphere and the cylinder, he basically stops his commentary and he inserts an anthology of 12 solutions to the problem of doubling the cube. I say 12 solutions, although the people who actually wrote this solution, or the authors of this solution, are just 11, but there is one solution which is reported in a double version, which is the solution of Menaechmus. So I say 12 solutions, but actually the people, the geometers to whom this solution are attributed are 11. And the 10th, or actually the 11th solution is Eratosthenes' solution. And it's very interesting then the way this letter reach us. And so as in the PDF, in the document that I circulated, where there is the text in Greek of the letter, and there is the, I divided it into, and there is my translation. I divided the text into 10 sections, and I ask you to try to think about a possible title for each section. And so the way I structure my presentation is to go through each of these 10 sections, defining a title and trying to see what these sections are telling us and the peculiarities behind each of them. So the first one is just the address.
Allow me to interrupt you for 1 second.
Yes.
Just for the people who entered late, I have attached in our chat the handout of Sara. So I strongly advise you to open this PDF at the moment of presentation, so you could have the text and the translation. All right, if you scroll up on chat, you will see it. If someone has any problem, just send me a private message so I don't interrupt Sara, and then I will forward the text. Thank you. Sorry, Sara.
No problem. Thank you. And yes, although I will, I pasted some passages also in the slide, so some passages are there. And of course, you can find many translations of this letter. I just put mine because I had to translate it for my dissertation. And so actually, I thought of sharing it in case you see things that you think that I could improve. And I would be very, very happy to hear your suggestions and comments and criticism. So the first point, number 1 in my handout, is definitely the address, so the reference to King Ptolemy, to whom Eratosthenes addresses this letter. So the big question is, the 2 big questions are, why a letter to the king with such a content? namely a solution to a problem, the problem of doubling the cube. And this brings me to the second question, which is, are we sure that the letter is authentic? Because you see, while you're reading it now, it's such a nice piece of writing, which, as I said, it makes sense if we think that Eratosthenes was an intellectual inside the Library of Alexandria. But at the same time, letters are easy to forge. And so there is this question, there is the problem of the authenticity. And here I'm going to refer to two big names in the field of philology for sure, the first one mainly, and in the field of history of Greek science, the second one. Because we have Wilamowitz, who thinks that the letter is not actually authentic. He thought that the second demonstration reported in the letter and the epigram are authentic, while the rest of the letter is just the product of a forger who basically rely on the epigram, and he wrote the letter on the basis of the epigram. And the second opinion is the one of Knorr, who actually, in his book, many pages are devoted to try to reply point after point, step after step to Wilamowitz's comments on the, and to Wilamowitz's thesis on the inauthenticity of the letter. And his conclusion is, granted that in principle, one cannot establish with 100% certitude the authenticity of any document whose authorship is disputed, we can nevertheless conclude in the present instance that Eutychius' test of Eratosthenes' letter is far more likely to be authentic than not. And he gives a lot of reasons, and he makes a very detailed analysis of the language which appear in the letter. And there is one detail that I will refer to later, which I think that is just one example, but is very telling, I think, an argument in favor of the authenticity of the letter. So in any case, for sure, the practice of prefatory, and just to say, I think that Knorr is right. I mean, I was persuaded by all his arguments, and I couldn't add much in the sense that he truly investigated the letter under many points of view. Having in mind specifically the issue of the authenticity, what I tried to do in my dissertation was to raise other points in favor of the authenticity, other points in general about the letter, which were interesting, I think, and which make better sense if we assume that the letter is authentic. But already Knorr analysis of the letter is very precise, let's say. So for sure, the practice of prefatory letters at the beginning of scientific texts was common. Archimedes addresses at the beginning of his treatises, he addresses them to some of his colleagues, Conon, Dositios, and even Eratosthenes himself, as we are going to see. And Eratosthenes' letter shares the main features of these prefatory letters. I said Archimedes, but there is also Apollonius. There are other authors, of course, who wrote prefatory letters at the beginning of the treatises. Eratosthenes' letter shares the main features of these prefatory letters. For example, the reference to his predecessor, the originality of his own contribution. Yet his letter, in a way, is different, because at the end is now followed by a treatise. It contains in itself all the geometrical content that Eratosthenes wanted to deliver, and is not directed to a specialist, but to the king, although we have an example also in Archimedes with Gelon, but still is interesting, the fact that Eratosthenes, he is providing a complete proof of his solution inside the letter, and he expects Ptolemy III to be able to understand it, although of course this could be this part at least could be fiction, in the sense that maybe he was not thinking that Ptolemy could understand everything, but still he wanted to deliver his content addressing specifically the king. And we will see also why he does so. And as I said, Archimedes himself actually addresses one of his treatises to Eratosthenes. And here the issue is the following. Now, when we think about ancient science, one of the questions is, was there a community? Because nowadays we have scientific communities, of course, no? And scientists are always in contact with each other, and science actually goes on thanks to the collaboration of many scientists at the same time. So the question is about whether in the ancient time there was something similar. And Eratosthenes never, at least in the fragments that we have, he never referred to Archimedes. But Archimedes addresses to Eratosthenes a fundamental treatise, which is the method of the mechanical problems. And what is extremely interesting is the fact that the method strikes among the treatises of Archimedes, because is for us, for sure you saw it already, but for us it's like a way to go behind the scene, to see Archimedes' reasoning behind what we have in the main treatises which are preserved. And it's super interesting because it raises the problem of the relationship, dialogue, contrast perhaps between geometry and mechanics, which is actually a very interesting, and also I would say is difficult to define exactly, I think, because at the beginning I thought that it was very clear what geometry, pure geometry is and what mechanics is, no? And the aims and the premises behind these two disciplines, but actually it's more complicated than that. Because if you read the pseudo-Aristotelian mechanical problems, if you read like the method of Archimedes, if you read Vitruvius, if you read Philo and Hero, you see that there is a constant tension and dialogue between the disciplines and between geometry and mechanics. So that was, yeah, and that is very interesting. And this is one aspect which is present in this text, the method of mechanical problems. So Archimedes decided to address this text to Eratosthenes. And it's interesting to see the way he addresses Eratosthenes. And here I put it translation. Seeing moreover in you, as I say, an earnest student, a man of considerable eminence in philosophy, and an admirer of mathematical inquiry, I thought fit to write out for you and explain in detail in the same book the peculiarity of a certain method, by which it will be possible for you to get a start to enable you to investigate some of the problems in mathematics by means of mechanics. And here there is a little bit, not a little bit, there is a puzzle, because on the one hand, if we stay with what Archimedes tells us, here, what we read, the idea is that he had a good consideration of Eratosthenes. Although it doesn't call him specifically a geometer, he says that he is that he has a considerable eminence in philosophy. And I did a search in the TLG, and philosophia appears only here in Archimedes' corpus. And he defines him as an admirer of mathematical inquiry. But on the other hand, we could also think that perhaps there is some irony behind that. And this is one way some scholars tend to read this. So that actually Archimedes was considering anyway himself a step above the other geometers, and even people experts in geometry or interested in geometry like Eratosthenes was. For sure, we have to take into consideration that one of the reasons why Archimedes addresses his treatises to people in Alexandria is because it was a way for him to let his works be known in Alexandria. So it was a way for him to connect himself from Syracuse to Alexandria. And this brings us back to the idea of there is a scientific community. There was not a scientific community in the sense, in the way it is nowadays. There was the idea of someone else before me did something, I can do something to improve it and to make things better, and my achievements are better than what other people did in the past, and I can improve things. And this is something that we find in Archimedes, and this is something that we find also in Eratosthenes himself in the letter, because at the end what it does is to say, people before me tried to solve the problem, but they couldn't, while I did. I solved the problem, or at least they couldn't. They could, but they could in a demonstrative way, while what I'm doing is to solve it in an instrumental way, which makes my solution way easier and way more useful than the solutions provided by my predecessors. So then we can go, after this long point one, we can go to the second point in my handout, which is right at the beginning of the letter, we find this. So Eratosthenes starts the letter in this way. They say that one of the ancient tragic poets represented Minos as constructing the tomb for Glaucus, and having found out that it was 100 feet long on each side, he said, "You have chosen a small sepulchre for a royal tomb, let it be double, but not to ruin its beauty, double quickly each side of the tomb." So we are brought immediately to a mythical context, or at least we are brought to a very ancient period. We are brought to the island of Crete and to the story of Minos and of his son. I will refer briefly to this myth because I think that there is a point of connection between this reference to the myth here in the letter and Eratosthenes' activity as an astronomer. These verses, by the way, if you are interested, people try to understand which tragic poet we are talking about. Some scholars say that it is Euripides. Other scholars say, no, it is a minor tragic poet. We are not able to define him. So is a matter of debate, actually. But the myth of Minos and Glaucus was actually famous, and was particularly famous in the Hellenistic period for a specific reason. So the myth goes in this way. Minos had this son, Glaucus, who one day was playing around, and he ended up falling into a jar of honey, and he died. So what Minos tried to do was to find a way to resuscitate his son. And he found out, thanks to an oracle, that if he was able to find a seer who could have replied to an enigma, to a riddle, this seer would have been able to actually solve, would have been able actually to bring Glaucus back to life. And this seer ended up to be a certain Polydus. Polydus was able to solve the enigma, which I'm not going to tell because it's too long, but in any case, he was able to bring Glaucus back to life. But what happens is that, unfortunately, Glaucus ends up Polydus basically was not, I mean, the story goes that Polydus and, because there are many variants of the story, but my main point is that at a certain point, Polybus and Glaucus were closed inside a tomb together. And the thing is that inside this tomb, two snakes appear. And this is what is represented in this cup, where we find a representation of the tomb with Polydus and Glaucus, and also with a snake below. Is very, very thin below, but is actually represented there. And this myth of Polydus and Glaucus was very famous during the Hellenistic period for a specific reason, because actually it was used as a way to represent a specific constellation. So there is a constellation which is called Ophiuchus, which represents a man with a serpent in his hands. And this constellation was described inside texts like the Katasterismoi as representing either Polybus or actually Asclepius having a serpent in his hand. And what is interesting is the following, is that Archimedes wrote a text entitled Katasterismoi, as I said, and we do have the story of Polydus and Glaucus, which is told to us by Hyginus in his Fabule and also in his work Astronomia. And specifically in the Astronomia, Hyginus refers to Eratosthenes and to the myth of Polydus and Glaucus. So I believe that one of the reasons why Eratosthenes was interested in this myth specifically is because he worked on this myth also for his text on astronomy, on his Katasterismoi. So if you have questions later, please let me know. But yeah, there are many variants of this myth. But what is the important point is Polydus and Glaucus together with this snake and the fact that there was this need to construct a tomb for Glaucus. Okay. Now, the problem which is brought up in the letter is that the builders in Crete tried to build this tomb for Glaucus. Minos thought that the tomb was too small, and so he asked the builder to make the tomb double in volume. The tomb apparently was cubic in shape. And what the builders did was to double the side of the tomb. But in this way, they ran into a terrible mistake because the tomb that they end up constructing was actually 8 times the original tomb. And here the question is, does this mistake remind us of another very famous geometrical mistake, very similar? Of course it does. It reminds us of Plato and the Meno. Oh, sorry. Of Plato and the, where we have the same mistake made by the slave, who, of course, no, the question is, you have a square, how do you get a square double in area? And what the slave thinks of doing is to double the side, and what he actually gets is a square which is 4 times the original square. And this was wrong, because actually what he needed to do was to construct a square on the diagonal of the original square. So this is already a point of connection between the problem of doubling the cube and Plato. So as I said, of course, doubling the side is not the way to obtain a cube double in volume, a given cube, because what you will get is a cube which is 8 times the original cube. So the question is, how would you double a cube? I mean, when I read for the first time the letter of Eratosthenes, I was like, okay, here, so the problem is doubling this cube. Now, what would I do as a student nowadays to double a cube? And my first thought was, okay, for example, I have a cube, the side is 2, the volume is 8. I want a cube which is 16 in volume. What do I do? And I was like, okay, I just take a calculator and I will do the cubic root of 16. And in this way, I would get the side. And of course, the problem is that 16 is not a perfect cube. And so we end up in the problem of irrational numbers, and which is the same problem that we had with the diagonal. And so how to solve this? Of course, the geometry, because arithmetically it was not doable for ancient mathematicians because of the problem of irrational numbers. But in the same way, they were able to solve the problem of squaring of doubling the square using geometry, namely using the diagonal of the square. They could have found a way, a geometrical way, to actually not get the amount that that side is supposed to be the side of a cube, which is double in volume compared to another cube, but to be able to draw, to actually get through a geometrical procedure to draw the side of this cube. And this is what they try to do. And here we enter to the third part of the letter. In the third part, we are told this. Many have been puzzled for a long time, but then Hippocrates of Chios first realized that if it was possible to find two mean lines in continuous proportion between two straight lines, of which the greater is the double of the smaller, the cube would have been double. In this way, the puzzle was converted by him into another, not inferior puzzle. So here we find a new character in the story, because basically what the letter does is to tell us the story of the problem, starting from Minos and Glaucus. The second step is Hippocrates of Chios, who lived in the 6th century BC, who was the first one, as far as we know, to write a book on the elements, who found a partial solution to the problem of the squaring of the circle, and importantly, who reduced the problem of doubling the cube to the problem of the two mean proportional lines. What does it mean, the two mean proportional lines? Actually, before that, what is this reduction? So what Hippocrates of Chios did was to transform the problem of doubling the cube, which is said in this way, expressed in this way. You have a cube, you want to create a cube which is double in volume. He transformed it into another geometrical problem, which is the problem of the two mean proportionals. And what is transferring of a problem, of a geometrical problem to another geometrical problem is called is apagoge. Apagoge is a fundamental geometrical tool which is defined here by Proclus. Reduction is a transition from a problem or a theorem to another, which, if known or constructed, will make the original proposition evident. So the idea is that rather than solving the problem of doubling the cube as it is, you solve another problem which allows you to solve then the problem of doubling the cube, which is actually a specific instance, a specific problem related to the more general problem of the two mean proportionals. But two means proportional between two given lines, what does it mean exactly? So here we enter into the big field of proportion theory, which is a fundamental component of ancient Greek mathematics. And proportion is, properly speaking, in ancient Greek, analogia. And properly speaking, analogia is only the geometrical proportion. The geometrical proportion is an equality of ratios. A is to B like B is to C, for example. So 2 is to 4 like 4 is to 8. This is, properly speaking, proportion. But then we have other kind of proportions, which are actually not true proportion because they are not equality of ratios, but which were put together together with the geometrical proportion, which are the arithmetical proportion, the harmonic proportion, and then other proportions. Although I use the word proportion because sometimes we find the word proportion, but actually it's better to talk about this as means rather than proportion. But this is just a reference. What interests us is the geometrical proportion, the one which is properly speaking called analogia. So what we want to find is to find a sequence of segments which are in this specific relation, meaning which are proportionate one to the other according to a geometrical proportion, which is represented here. And the instructions are the following to solve the problem. So you have a cube whose side is A, basically. You want to find a cube which is double in volume. So what you have to do is to double A and then find two mean proportional lines between A and D, which correspond to 2 times A. And if you are able to find these two mean proportionals, the cube built on the first of the two, namely B, will be double in volume to the cube built on A. And this is the solution to our problem. The problem is, how do we find geometrically these two mean proportionals? And here we find that we get to the third section of the letter to King Ptolemy. And this section is about an anecdote. So we move from basically the setting of Crete, of the island of Crete, and of this ancient past. We move to Hippocrates of Chios in the 6th century, and then we move to the time of Plato. And we get this very interesting anecdote, which is the following. They say that after some time, certain Delians, trying to double a certain altar in accordance with the oracle, fell into the same puzzle, and sending an embassy to the geometers who were with Plato in the academy, they asked them to find what they were looking for. So we have this story about a Delian oracle. We get from other sources that actually the problem is that there was a plague in Delos and people didn't know what to do, and the oracle told them there is an altar and there is an altar to Apollo. Try to hold this altar, and if you're able to do so, the plague will stop. The geometers were not able to actually do it because what they could do was to double the side, and in this way, they couldn't get the right solution. And so what they did was to send an embassy to the geometers in the academy. And from this anecdote, the problem of doubling the cube is known with three names, with three labels, which is the problem of doubling the cube, the problem of the two mean proportional, and finally, the Delian problem. So as I said, there are many sources for the anecdote on Plato and the doubling of the cube. So many sources for the Delian anecdote. And besides Eratosthenes' letter, another one, which is related to where Eratosthenes is the protagonist, where Eratosthenes is the one who refers to this anecdote, is Tionosmirna. Tionosmirna is the only author who reports the title Platonicos twice in his work, the Expositio Rerum Mathematicarum ad Legendum Platonem Utilium. And this is what we find actually right at the beginning of Tionosmirna's work, which is what I'm going to read. For Eratosthenes, in the subtitle Platonicus, says that since the god announced by an oracle to the Delians to build an altar double in size to the existent one in order to get rid of the plague, a great uncertainty fell on the builders who were trying to find out how a solid could be made double of another solid. They went to ask Plato about this topic. He told them that the god had made this prophecy to the Delians, not because he needed an altar double, but because he was commanding and blaming the Greeks who did not care for mathematical subjects and held geometry in little esteem. Now, reading these lines, what we get is that there are some differences. There are some things in common, but also some difference with what we find in the letter. And what the main point of departure between the two is that in the Platonicus, we get the information that Plato gave a reply to the embassy, and this reply is that actually the god didn't want an actual altar double in volume. He just wanted the Greeks to care more for geometry. And this anecdote brings us to, first of all, the question of why Plato and the problem of doubling the cube, why to connect the two, because I refer already to the Meno, but actually, do we have in other passages of the dialogues a possible hint, a possible reference to the problem of doubling the cube? Although, I mean, in the Meno, we don't have a reference to the problem of doubling the cube. We just have a reference to a problem which is very similar to the problem of doubling the cube. But do we have in the dialogue a more striking possible reference to the problem of doubling the cube? And what certain scholars think is that we have a reference in the Republic. Actually, this is contested because probably here Plato is just referring to stereometry in general. Here in the Republic, Plato is talking about the different mathematical disciplines, and he's talking about stereometry specifically, so geometry in the third dimension, And probably this reference to Tom Cuban-Auxen is actually a reference not specifically to the problem of doubling the cube, but here there is actually much literature on the problem. And so just to say that it is a problematic point, and actually scholars think that this is an actual reference to the problem of doubling the cube. What I found reading other texts of Plato, or in this case, not of Plato, but belonging to the academy, is that we have another interesting passage, I think, where the problem of doubling the cube is actually referred to specifically. This is a spurious dialogue, which is the Sisyphus about knowledge. And here we have a parallel between the problem of doubling a square and the problem of doubling a cube. And this is a specific parallel which is made, because what we read is, or again, take the doubling of the cube. You know, don't you? The geometers try to find out by reasoning how big it is. So here we do have the diplasiasmos, to cubo diplasiasmos reference. And right before there was actually a reference to the doubling of the square. So my point with this reference to the Sisyphus is that, okay, perhaps we don't have references to the problem of doubling the cube specifically in the dialogues of Plato, but at the time of Plato, the problem of doubling the cube was a main geometrical problem, and for sure this problem left some fascination inside the academy, to the point that in a spurious dialogue, someone, the author of the Sisyphus, which, as I said, is considered to be a spurious dialogue, refers specifically to the problem of doubling the cube in parallel to the problem of doubling a square. Now, the other big question is not only why Plato and the problem of doubling the cube, but also what do we get from the anecdote of Plato replying to the embassy of the Delians? Because we have this. So in the letter, Plato doesn't say anything. Simply Plato is referred to because the geometers inside the academy are those who start working on the problem of doubling the cube and who actually try to find solutions to the problem of doubling the cube. And they did, in fact. Then we have other authors like Plutarch who use the problem of doubling the cube to show a specific point, to provide a specific representation of what Plato thought about mathematical disciplines. And this passage, I'm not perhaps going to read all of it because I know that it appeared already in one of your previous classes, but the idea is that Plato got angry at Eudoxus and Archytas because they tried to give actually a solution to the problem of doubling the cube, which was too mechanical, was too practical. And for this reason, they were going too far away from the actual true pure geometry, which is actually the one that you need to practice and to study in order to reach higher truth. So the idea in Plutarch here is that if you do mechanics, you're not doing the right thing. Namely, what you need actually is to do pure geometry, geometry detached from the sensible world, because this is what helps you to reach higher truth. So this is the picture that we get from Plutarch. And I will refer to this picture afterwards, after we see what Eratosthenes actually say about Archytas and Eudoxus and also Menexmus' solution. So Eratosthenes says in the letter, among those who apply themselves with diligence and try to take two means of two given lines, Archytas of Tarentus is said to have found them by means of semicylinders, Eudoxus by means of the so-called curved lines. But it happened that they all gave solution in a demonstrative way. And they could not give a practical construction nor make it useful, except to a small extent Menexmus, and also with difficulty. So here we get three names. Archytas of Tarentum, 1st century BC, famous, I would say very famous for harmonic theory, in the field of harmonic theory, Eudoxus and Menexmus, all these geometers are related to the environment of the academy. And the problem is that what Eratosthenes is telling us is that they gave a solution to the problem of doubling the cube, which is too demonstrative. So basically it's the opposite of what Plutarch tells us, because Plutarch tells us that they gave a solution which was too instrumental. Eratosthenes tells us that they gave a solution which was too demonstrative. So we run in front of a puzzle, one of the main puzzles of this letter. Fortunately, we do have Archytas solution and we do have Menaechmus solution. And thanks to that, we can actually check what Eratosthenes and what Plutarch tell us. And Archytas solution is a solution which is very complex, and it involves the intersection of three solids, a cylinder, a torus, and a cone. And motion is involved. And this is, I'm just referring to it, but the concept of motion is very important in Archytas solution, and also is very important in relation to the question about the relationship between geometry and mechanics. And in the letter, Eratosthenes refers to Archytas solution with the word hemiculindron in genitive, and then in the epigram, he refers to colindron. So we lost the hemi. And this is actually one point that Knorr stresses when he says, look, a Forger couldn't have guessed that it couldn't have gone from the epigram, which tells us about culindron, it couldn't have gone to the hemiculindron. So Knorr says against Wilamowitz, it's not true that a Forger could have used the information from the epigram to write what we find in the letter, because actually in this reference to Archytas solution, the letter is more precise compared to the epigram in the word which is used to refer that Archytas solution, because in the diagram I write cylinder, but as you see, what we actually need in Archytas solution is not the entire cylinder, but just half of it. So this is more precise, a more precise reference to Archytas solution. And Eudoxus solution, we actually don't have it because Eudoxius thought that it was not worth referring it. Why? Because the reason is that, so Eratosthenes says that Eudoxus solution is based on these Campulae grammae, and Eudoxius says, but at the end, the Campulae grammae do not appear in Eudoxus solution. So there is some incongruency, incoherency in Eudoxus solution. So he doesn't report this solution. Actually, it is hard to define exactly what these grammae are. And one place to look at is, for example, Eudoxius himself, who in another passage in his commentary on the sphere and cylinder says that curved lines are, in general, all the possible kinds of lines which are not straight lines. But it's problematic to understand how, to reconstruct possibly how Eudoxus solution was. And then we have Menaechmus solution, which use actually conic sections. So the intersection between two conic sections, either two parabolas or one parabola and one hyperbola. So the solution that we saw of Archytas and Menaechmus in particular do not look like a solution based on instruments. So actually the way Plutarch pictures them looks very much like Plutarch had an agenda. He wanted to, the moment when he refers to this anecdote, he wanted to give a certain picture of Plato and of Plato's approach to mathematics. And in order to do so, he makes up the idea that Plato reproached Archytas and Eudoxus for their solution, because these were too based on instruments, too based on the sensible realm. But actually, this is not the case. And what actually Eratosthenes reports us is a more, when he reports the daily anecdotes, is a more reliable, or at least a version of the anecdote which makes more sense with the solution, if we think of the solution that we actually have, the solution of Archytas in particular, because at the end of Eudoxus we don't have it. And then this brings me to Eratosthenes' own solution, because Eratosthenes is very proud of his way to solve the problem of doubling the cube. He says, my solution is better compared to the previous ones. Why? Because it is instrumental. And evidently, Eratosthenes didn't see any problem whatsoever to talk about his solution as instrumental. Actually, he's very proud of it. And he says, in this way, it is easy. In this way, it is actually useful. And this is the way he presents his solution. He says, but a certain simple instrumental solution has been devised by me, by means of which we will find not only two means of two given lines, but as many as one desires. So he says that, as I said, his solution is instrumental, is easy. It allows us to get not just two means, but as many as one wants, and it has multiple uses. So Eratosthenes' solution is actually an instrument. So he built and invented an instrument to solve the problem. This instrument is the famous mesolabos, the means taker. We don't find the name of the instrument in the letter. We find the name of the instrument in Pappus, with the other important testimony of Eratosthenes' solution, which I didn't give to you to read, because otherwise things would have gotten more complicated, but Pappus does not report any letter. It just reports Eratosthenes' solution, namely how the instrument works. But Pappus reports the name of the instrument, mesolabos, which appears also in Vitruvius in the Architectura, because Vitruvius refers to Archytas and Eratosthenes' solution to the problem of doubling the cube, and Vitruvius talks about the mesolabos. And here, what was very interesting for me was to try to understand what we mean when we talk about a solution which is demonstrative or only based on geometry, and a solution which is instrumental. Because also when Pappus talks about different solutions to problems, he says, look, in principle, the problem of doubling the cube is a problem which requires you to use certain kind of geometrical lines, which are the conic sections. These are difficult to draw. These are difficult to use. And so it is actually better to use an instrument and to find a solution in an instrumental way. So my point here is that there seems to be this tension, which is a dialogue, which is a relationship between geometrical problems and ways to solve them. And here we have this idea that instruments can help to solve certain geometrical problems. And this is what Eratosthenes did. Rather than using conic sections, as Menechmus did, he invented an instrument. And his instrument made the solution actually easy to get. And we will see why. Yeah, this is just the chart that I asked you to fill in the PDF that I sent you on Pappus, because it's very nice the fact that Pappus distinguishes between three different kinds of problems. And he says each problem has its own set of lines which you should use in order to solve them, depending on the kind of problem we're talking about. Since the problem of doubling the cube is a solid problem, in principle, you should use conic sections to solve it. So Eratosthenes, when he talks about the problem of doubling the cube, he says this problem, the solution to this problem that I'm giving, can actually have many uses, not just doubling a cube. The first one, so he lists three uses. The first one is the geometrical one, namely the problem of doubling the cube. So if you want to double a cube, but also if you want to reduce a solid to a cube or to transform one solid into another one. The reason why I'm saying this, because actually, I mean, with the solution to the problem of doubling the cube, you could also transform, for example, a rectangular prism on a square base. You can transform it into a cube. if you are able to find two mean proportional between the two sides of your parallelepiped. So this is actually a way to go from one shape to another shape. Okay. Then there is a second use that Eratosthenes lists, which belongs to everyday life. And so here we move from, let's say, the realm of geometry, abstract geometry, or perhaps even architecture, actually, because Eratosthenes says, yeah, to change one shape from one solid from one shape to another, but also in this is in the case also of altars and temples. So there is this reference to actually geometry which could be applied to architecture, and of course to the there is here a reference to the anecdote, the Delian anecdote. But then he refers to everyday life in Alexandria, because he says the problem of doubling the cube can help you to measure dry or liquid goods. And what I was able to find here was actually very interesting. So this method of measuring things, of measuring either for corn measure or for liquid measure, these so-called secomata, which are like these pots of different size, which helps you to measure and to weight things, and which were in use in the Hellenistic period. And finally, a super interesting use for Eratosthenes solution. So I didn't know anything about catapults before reading this letter. I didn't know what Eratosthenes meant when he referred to the fact that the problem of doubling the cube could have helped him, could have helped actually the builders of catapults to build catapults in a more effective way. And then I found out a lot of things. I found out that during the Hellenistic period, there was much research in the context of Alexandria and of Rhodes specifically on catapults. And this is actually the picture that we get from Philo of Byzantium in his Belopoieica. He says, the object of artillery construction is to dispatch the missile at long range to strike with powerful impact. To this end, experimentation and most investigations have been directed. We shall recount to you exactly what we discovered at Alexandria through much association with the craftsmen engaged in such matters and through intercourse with many craftsmen in Rhodes, from whom we understood that the most efficient engines more or less conform to the method we are about to describe. So there was a lot of trial and errors. So the development of artillery, of the discipline of artillery construction, went on and developed through trials and errors. And apparently in Alexandria, at the time of Ctesibius, more or less, they defined this formula, the calibration formula. So the idea is that you can build a very efficient catapult if you I've defined a certain sets of proportions which are based on a specific measure, which is here, which is the measure of this hole here. Once you have, so you have a set of proportion for all the components of the catapults, and all these components depend on the measure that you need to define for this hole specifically, for the diameter of this hole specifically. And the problem is that to define the diameter of that hole, what you need to do is to use a formula, which is written here, which involves the cubic root. And the problem is, if you have to define the cubic root of a number which is not a perfect cube, what do? Here, you can use the problem of doubling the cube, because the problem of doubling the cube allows you to get to extract the cubic root of a number which is not a perfect cube. And so here is the reason why the problem of doubling the cube is useful for building catapults. Okay, then the three sections of the letter 6, 7, and 8, I thought to gather them together, because In 6, we have the first geometrical proof, as I call it. Number 7 is a description of Eratosthenes' instrument, and number 8 is the second instrumental proof. So how actually work Eratosthenes' solution? How does it work? So this is how the instrument, how the mesolabus is structured. You have a frame, which is this one. Then you have 3 plates. Possibly all this is made of bronze because it's more resistant, of course. And these plates are rectangular plates. We suppose that we have the diagonal represented because we need it afterwards. What we do is to basically slide the first plate and the second plate. But before that, sorry, we need to define our segments because you should remember that the problem of doubling the cube means to find 2 mean proportionals, 2 segments mean proportional between two given lines. So we need to have these 2 lines. What are these 2 lines? These 2 lines are line A, this one, and line D. And in order to double the cube, you need to have, specifically, you need to have the second line A, the double of this one, D. Actually, in my example above, I used the opposite letter, but the idea is the same. Namely, one needs to be half of the other. And you need to find the 2 mean proportional between these 2 lines. In order to do so, we can use these plates. One plate needs to slide above the central one, which stays fixed. The other plate slides below. And once we reach this kind of configuration, namely when we reach a point, when we reach a situation in which we get this intersection, which needs to be an intersection between the line which defines the end of the plate, the diagonal of the plate below, and a line which conjoin these intersecting points, we have found the 2 mean proportional between A and D, our mean proportional B and C, which means that if I build a cube on C, this cube will be double in volume compared to the cube that I built on D. And the cube built on B will be double in volume to the cube that I built on C, and so on. It's simple. The geometry behind it is very simple because the proof is just about showing that all these triangles, like this one here, this one here, this one here, and then this one here, all these triangles are similars. And for this reason, you can build a series of proportions between sides. And in this way, you end up demonstrating that actually A is to B, like B is to C, and C is to D. And what Eratosthenes is very smart in underlying is the fact that you need to be very precise while you are performing, while you are using the instrument. And he underlines the akribia that you need to have when he describes the instrument, because he says a small frame, plintion, either of wood or of ivory or of bronze, is made fixed, and it has 3 small equal plates, as thin as possible, of which the middle one is fitted, while the other 2 can be pushed forward in groups of sizes and proportion as one thinks. Indeed, the steps of the demonstration are accomplished in the same way, which means that you could use 2 segments, one double the other, and in this case, you double the cube. But you could have also different kind of relationship between these 2 segments. To take the line in a more precise way, it is necessary to use art. And here we have the akribesteron and the philokteon, so that while bringing together the small plates, all the things remain parallel and without a gap and join each other in a uniform way. Because Eratosthenes is thinking, what I'm doing here, what I suggest to do is to use an instrument to solve this problem. The thing is that behind the instrument, there is the geometry. Of course, the geometry is perfect because we are talking about drawings which do not have drawings, which you could think of drawings in your mind, which do not have actually thickness. No, our imaginary or drawn rectangles do not have any thickness, while the instrument does have some thickness because of the frame, because of the plates, and this thickness take away a little bit of the precision of the solution. And so what Eratosthenes does in a very intelligent way is to say, try to be very careful while you manage the instrument and try to create an instrument where the plates are actually super thin. So like they are almost like a perfect imaginary abstract rectangle. And in fact, Eratosthenes felt the needs of providing two proofs in his letter. One proof, which is the more complete one, which I'm going to call the geometrical proof. And Eratosthenes himself talks about these things that have been demonstrated on geometrical surfaces. And then he provides a second proof, which is the one which actually refers to the components of the instrument. And his geometrical proof is typical, the typical proof of ancient Greek mathematics with all the perfect parts. And this is the first one. And is complete in all these passages. Well, the second proof is much more scanty with just few references. And also there is a clear reference here, there is a reference here in the tu cento organo pinacas. So a reference to the actual instrument. So it looks like Eratosthenes feels the need of not just providing the proof, which is actually the one that he says that it was inscribed on the votive monument where the instrument was placed, which is the second one. But in the letter, he has also the geometrical, the properly and complete geometrical proof. And this is the reason why we get two proofs inside the letter. Now, the big question is, for me at least, which I tried to answer, was why is Eratosthenes' solution instrumental? Why do we call it instrumental specifically? Of course, it is based on the use of an instrument, the mesolabus. This instrument allows geometrical surfaces to perform motion in the three-dimensional space, and very interesting aspect of the solution. And also it is instrumental because Eratosthenes underlines the fact that his solution is easy and is applicable in the field of mechanics afterwards. So Eratosthenes, what did he do? He invented this instrument and then he placed this instrument on a column. And it tells us, luckily, because we don't have the instrument anymore nor the column, it tells us what we should have expected to see somewhere in Alexandria, where we don't know, in a place accessible to the public, inside a palace, we don't know. So what we were supposed to see, a column with an instrument, with the instrument on the top, with the proof below, the short version of the proof, the instrumental version, the diagram, one single diagram, the one which represents already the two means which are already defined, and finally the epigram. Now, right before ending the letter with the epigram, Eratosthenes underlines the versatility of his solution, because it says, my solution will allow you not just to take two mean proportional between two lines, but you can actually get more mean proportional. You just add more plates to the frame. And the second point is the fact that you can define in which relationship you want to have your two segments between which you want to find the mean proportional. So it doesn't need to be necessarily a relationship 1 to 2. It could be other form of relationship. So what he underlines is that his solution is actually is very versatile. Finally, we have the epigram. The epigram, which is of course a piece of writing, And this is very nicely constructed because we have the first part, which is about Eratosthenes referring to the uses of his solution. The second part, where Eratosthenes refers to other solution contrasted to his own solution. And finally, he praises the king. And of course, the praise to the king should be inserted inside the context of Alexandria and of the Ptolemaic patronage. And what, as I said, what Eratosthenes does inside the letter is to underline that his solution is useful also for the king who wants to build catapults, for the king who wants to take care of everyday life in his city, for the king who is interested perhaps in temples and altars. So he wants to underline the utility of his solution for the king, for whom Eratosthenes worked, of course, in the library and the museum. And at the end, Eratosthenes seals the epigram with his own signature, basically. And so here I reach my conclusion. So Eratosthenes was a polymath, as we saw at the very beginning, and his interest in philosophy is an exception in the context of Alexandria. But he was definitely interested in Plato's ideas on mathematics. He was interested in Platonic philosophy, and he was interested specifically on Plato's approach to mathematics. So what I did in my entire thesis was to keep creating these links that I show you in the first part of the presentation, finding these links which connects Eratosthenes' activity with Plato's own approach and views to the study of mathematical disciplines. And my conclusion at the end is that what Eratosthenes did was basically to draw some contents from what we find in Plato's dialogues. He noticed how much importance Plato paid to certain topics in the field of the mathematical disciplines. For example, to the diatonic genus in harmonic theory in the Timaeus, to the importance of proportions in the structure of the word soul and of the heavens in general, the importance given to the research in the field of geometry, to the importance given to the topic of the harmony of the spheres and in the sky, and in general to proportions, because there is this famous sentence in the Timaeus when like the demiurge is trying to define how to put together the elements to create the word body, and it says like the best bond between fire, earth, air, and water is analogia, is proportion. This is the most powerful and the most beautiful bond that you can have between elements. So there is, Plato understood that at his time, proportion theory was a big thing. Archytas was very much into proportion theory, and he used proportion theory in music. And Eratosthenes basically inherited this fascination for proportion theory, and the way he uses proportions and means in his works is very much influenced by Plato. And this is the picture that I gather from Eratosthenes, and also what I gather is that with Plutarch and with other authors afterwards, Middle Platonic or Neoplatonic authors, there is this idea that Plato was against practical mathematics, was against practice, basically. Eratosthenes, what he did was actually to put himself inside the tradition of the geometers inside the academy, to put himself inside this tradition, and he didn't see, or at least he didn't underline any contrast with the idea of providing an instrumental solution to the problem of doubling the cube, because at the end there is the component of the instrument which can be useful in order to reach certain solutions. And this is what I just said, so that Eratosthenes places his own solution in the line of solution given by geometers related to the academy. As an expert of mathematics working in Alexandria, he's related to Archimedes, as we said, in this interesting way. And as an intellectual working for the Ptolemaic family, he underlines the utility of his geometrical activity. And his solution to the problem of doubling the cube reflects the relationship, tension, dialogue between geometry and mechanics of his time. And it is in this light that I read Eratosthenes' solution, especially in connection to the solution given by authors that are later than Eratosthenes, like Philo or Hero, or even Pappus, who all of them stresses very much the mechanical, the instrumental element, and like especially Philo for sure. So yes, this is more or less what an overview of my dissertation and my presentation for you for today. I'm very happy to answer any question, and thank you very much for your attention to all of you. Thank you.
Thank you so much, Sara. Thank you so much for that. I don't even know how to clap on Zoom actually, but anyways, so this lesson can easily be described as a discussion on a polymath from the past, from a polymath of the present. So I had a discussion with Sara some time ago when she asked me to give some guidance on how to structure this lecture, and I have specifically asked her to prepare the first hour as a horizontal discussion, meaning that you will get a broad idea of what is going on, and then to select a particular text for the second hour. We had the letter to Eratosthenes and create an in-depth analysis of the letter. In that way, you will get a sense of an ideal rectangle, which shows the depth that is required to master these very extremely difficult topics, including philology, mathematics, philosophy, history of science and music. This is 5, Sara, pentathlon as well. So I propose we have a 10-minute break, Thank you. And then we resume for the discussion, questions, and all the other things that you might want to ask for Eratosthenes, and even some things that may not have popped up in the discussion, but it is fine. We could discuss them in the broader sense of the Alexandrian era and the Alexandrian project in the library. Okay. So I propose to stop the recording. We will not have the recording during the question, guys. That's off right now. And we resume in in 10 minutes and for the discussion. Like we could have a brief discussion for 20, 30 minutes afterwards. Again, thank you so much, Sara. Thank you so much.
Thanks to you.